Functions are mathematical rules, sometimes also known as a machine. And what happens with a function is there's an input, something that goes into the rule, and out comes one unique output. The input is known as x, or the domain. We'll have a lecture later on domain. Output is y, otherwise known as the range. The notation for a function, we're going to call it f. So that's just the name of the function. And in here we're going to have a little x. And this is read f of x. It's not multiplying f times x. It's taking your function f, that's its name, and inputting the x variable. F of x is equal to y, the output. I input an x and I output a y. So for example, in the left-hand column, my input or my x variable. I'm going to input the x variable in the x position, and notice it says, the machine says add 2. So a drawing of this, or a diagram, is this is my machine that says x plus 2. I have an input area, so in comes 1. 1 is put into the machine, and out is 2. A 1 produces a 2 because the rule says whatever comes into the machine, add 2 onto it. 1 plus 2 is 3, and notice the relationship, the x-y relationship. So when I evaluate my function at 2, that's asking me to put 2 into my machine. My machine says add 2 to it, and I get 4. So my input, 2, produce an output of 4. So we pair them up. My input of 3 is going to say take 3 and add 2. 3 plus 2 is 5. When I input 3, my output is 5. Now we're going to take a look at this function. We can actually see it algebraically, f of x equals x plus 2, and we can see it on a graph. If I plot 1, 3, x is 1, y is 3, x is 2, y is 4, and x is 3, y is 5. If I connect those 3 dots, I form a line. Now those aren't the only 3 ordered pairs I can construct. We can construct as many as we want or need. Here's another function. F of x equals x squared plus 2x. So my rule is telling me every input, if I input negative 3 into my function, I square it, and then I add 2 times the input. Well, when I square negative 3, I get a positive 9. A negative 3 times a negative 3 is a positive 9. 2 times negative 3 is negative 6. When I add those two together, keeping track of your integers, I had $9, I spent 6. My output is 3. So I have this relationship. Negative 3 went into my rule. Positive 3 came out of my rule. When I try f at negative 2, I take negative 2 and square the entire input, add 2 times the input. Simplifying that, negative 2 times negative 2 is 4. 2 times negative 2 is a negative 4. When I add those two together, I get 0. So when negative 2 went into my rule, 0 came out of my rule. F at negative 1, repeating the process. Negative 1 squared plus 2 times negative 1. Negative 1 times negative 1 is a positive 1. 2 times negative 1 is a negative 2. $1, I spent 2, I'm in the hole 1. When I put in negative 1, I got out negative 1 as my output, or my y. Putting 0 into my function. Every x becomes a 0. When I square 0 and add 2 times 0, my output is 0. So now I'm at the point 0, 0, which is the origin. F at 1 is 1 squared plus 2 times 1. 1 squared is 1. 2 times 1 is 2. Adding them together, I get 3. When I put 1 in, I got out 3. And what we're going to do is get a picture of this function. It's going to look a little bit different than the one we did in the first example, plotting the first point, -3, +3. 3 in the left, +3 up. -2, 2 in the left, and up or down, nothing. -1, -1, 0, 0, and 1, 3. Now if you notice, those points don't form a line, but if I connect them, they're going to give me this general shape that looks like a U. We actually have a specific name for this, which we'll be talking a little bit about later. But it's going to form this U-shaped figure. So there's a few problems for you to practice on your own.